Some names now exist only in the pages of history books. They vanished from the Earth nearly 40,000 years ago, but they never truly left humanity. Around 1 to 2% of the DNA carried by many modern people outside Africa still bears their genetic legacy. And with every new archaeological discovery, long-held beliefs about the Neanderthals continue to be overturned. This is the journey to uncover everything modern science truly knows about the Neanderthals. Nearly 800,000 years ago, the ancestors of modern humans, Neanderthals, and Denisovans had not yet diverged into separate branches. For centuries, human evolution was often imagined as a ladder, with Homo sapiens standing at the very top. But archaeology, fossil discoveries, and ancient DNA have revealed the opposite. Evolution did not follow a straight path. It unfolded more like a branching tree, with multiple lineages growing side by side. Neanderthals were not our direct ancestors. They were a human lineage that evolved alongside Homo sapiens for hundreds of thousands of years. According to most of the evidence available today, the common ancestor of Homo sapiens, Neanderthals, and Denisovans was most likely Homo heidelbergensis, or a population very closely related to that species. Around 700,000 to 600,000 years ago, part of this population left Africa, spreading into Western Asia and eventually Europe. It was there that nature began shaping two very different evolutionary paths. While the populations that remained in Africa continued adapting to a warm climate with abundant food, those living in Europe faced prolonged ice age cycles, an unstable climate, and increasing geographic isolation. After hundreds of thousands of years, they gradually evolved into Neanderthals. Meanwhile, in Africa, another branch ultimately developed into Homo sapiens around 300,000 years ago. For nearly 400,000 years, Neanderthals dominated much of Europe and Western Asia, surviving multiple ice age cycles while hunting mammoths, woolly rhinoceroses, and wild cattle across vast, frozen grasslands. During that same span of time, Homo sapiens continued to develop primarily in Africa. Two human lineages shared the earth, yet they were almost entirely unaware of each other's existence. If the history of civilization spans only about 5,000 years, then the period during which they evolved separately was more than 60 times longer. That distinction also gave rise to a debate that lasted for decades. Were Neanderthals a separate species or merely a subspecies of modern humans? The answer became much clearer in 2010 when scientists at the Max Planck Institute successfully sequenced the Neanderthal genome. The results revealed that most modern people outside Africa carry about 1 to 2% Neanderthal DNA, evidence that the two groups encountered one another and produced offspring together roughly 50,000 to 60,000 years ago. That same year, a tiny bone fragment discovered in Denisova Cave in Siberia revealed the existence of an entirely new human lineage, the Denisovans, showing that the story of humanity was once far richer than we had ever imagined. Perhaps the most astonishing fact is not how different Neanderthals were from us, but how remarkably successful they became. They were not a failed evolutionary experiment. They were nature's answer to a frozen world. But how did that environment reshape their bodies? Why did they develop such large noses, massive rib cages, powerful muscles, and brains that were even larger than those of modern humans? Imagine living in Ice Age Europe, where temperatures remain below freezing for months at a time. Cold winds sweep across grasslands stretching for hundreds of miles. Trees are sparse, and food supplies are always uncertain. There are no permanent shelters, no modern clothing, and no reliable source of energy. Under those conditions, simply maintaining body heat is already a challenge. This was the world that shaped the Neanderthals. Fossil evidence shows that adult Neanderthal men were usually about 5 feet 5 inches tall, while women were around 5 feet. They were not tall, but their bodies were exceptionally sturdy, with broad shoulders, thick bones, and highly developed muscles. The muscle attachment points on their bones indicate that they regularly performed activities requiring tremendous strength. This is consistent with archaeological evidence showing that Neanderthals hunted enormous animals with spears at close range. Their short, stocky bodies and relatively short limbs were not accidental either. Two well-known biological principles, Bergmann's rule and Allen's rule, suggest that animals living in cold regions tend to have broader bodies and shorter limbs to reduce heat loss. Neanderthals did as well. Their bodies function like a natural heat retention system, helping conserve energy in a frozen environment. Another striking feature was their large nose, and studies using CT scans and airflow simulations suggest that the Neanderthal nasal cavity may have helped warm and humidify cold air before it entered the lungs, while also meeting the oxygen demands of a muscular body with high energy consumption. Their brains have also surprised many people. The average Neanderthal brain volume was approximately 1,450 to 1,600 cubic centimeter, larger than the modern human average of 1,300 to 1,400 cubic centimeter. What matters is how the brain was organized, and some studies suggest that Neanderthals devoted more neural resources to controlling their powerful bodies and processing visual information under the low light conditions of high latitudes. This suggests that evolution produced a brain best suited to their environment. Ancient DNA analysis shows that Neanderthals carried many gene variants associated with immunity, energy metabolism, and adaptation to cold climates. Today, many people outside Africa still carry segments of Neanderthal DNA that influence the immune system, circadian rhythms, metabolism, and the ability to adapt to the environment. In a sense, the biological solutions Neanderthals accumulated over hundreds of thousands of years still survive within our own bodies. However, fossils from different periods show that they also changed over time. Neanderthals who lived 350,000 years ago were not exactly the same as the final populations living in Europe around 40,000 years ago. Like Homo sapiens, they continued to evolve in response to an ever-changing environment. When we bring all these pieces together, we realize that their large noses, broad rib cages, short limbs, powerful muscles, and massive brains were not signs of a primitive human species. They were evolution's answer to one of the harshest environments that had ever existed. But if the Neanderthal body was shaped so perfectly for survival, just how extreme must the world that created them have been? We are about to enter Ice Age Europe, a world that not only shaped their bodies but also determined the fate of an entire human species. For nearly 400,000 years, Neanderthals had to adapt to an ever-shifting environment, where grasslands could become forests and then return to open steppe within only a few thousand years. During the coldest periods, enormous ice sheets covered much of northern Europe, while sea levels stood about 390 feet lower than they do today, exposing land that connected Britain to mainland Europe. When the climate warmed, the ice melted, the seas rose, and the landscape changed once again. Imagine that generations within your community had survived by hunting reindeer across vast grasslands. Then, within only a few centuries, that land became forest, the reindeer herds disappeared, and the knowledge accumulated over countless generations became almost useless. One of the most remarkable ecosystems of that time was the mammoth steppe. Contrary to what many people imagine, it was not a land buried beneath snow, but a vast expanse of cold, dry grasslands stretching from Western Europe across Siberia and all the way to Alaska, inhabited by enormous herds of woolly mammoths, woolly rhinoceroses, ancient bison, wild horses, and reindeer. For Neanderthals, it was a valuable source of food, but it was also a place where every hunt could become a battle for survival. A single charge from a bison weighing more than 2,000 pounds, or one mistake in front of a woolly rhinoceros weighing nearly 6,000 pounds, could be enough to kill a hunter. Yet something even more unpredictable is recorded in Greenland ice cores. Numerous Dansgaard-Oeschger events, during which temperatures in the northern hemisphere may have risen by approximately 15 to 30 degrees Fahrenheit, within only a few decades. Every generation of Neanderthals had to learn how to adapt to an environment different from the one experienced by the generation before it. At times, these changes became even more violent during Heinrich events. When enormous ice masses in North America broke apart and drifted into the North Atlantic, the influx of fresh water weakened the ocean current system, causing Europe to become colder and drier within a relatively short period. Grasslands contracted, vegetation declined, and animal herds were forced to migrate hundreds of miles in search of new food sources. Archaeological evidence shows that Neanderthals did not simply wait passively. They retreated into southern Europe when the climate became too extreme, then expanded northward again when conditions improved. That ability to adapt was the key that allowed them to survive through repeated ice age cycles. Beyond the climate, Neanderthals also had to share their environment with some of the most formidable predators of the time. Cave lions, cave hyenas, ancient wolves, and cave bears weighing more than 2,000 pounds all competed for the same food and shelter. Many archaeological caves contain evidence that humans and large predators occupied them at different times. This means that whenever Neanderthals entered a rocky cave to escape the snow and wind, they faced not only the cold, but also the question of whether the cave's true owner had already left, or was still inside. What is astonishing is that they did not merely survive, but mastered this environment for nearly 400,000 years. Today, many scientists no longer view Neanderthals as victims of the Ice Age. But if physical strength alone was not enough to help a human species survive for so long, what was the real key? How did they hunt enormous animals, create effective tools, and maintain their way of life in an environment that never stopped changing? Physical strength was certainly an advantage, but it cannot explain why a human species with a relatively small population survived across Europe and Western Asia for nearly 400,000 years. To endure hundreds of winters and repeated climate shifts, they needed more than muscle. They needed knowledge, the ability to plan, and most importantly, the ability to pass experience from one generation to the next. Archaeological discoveries made over the past several decades show that Neanderthals did not merely react to nature. They understood it and knew how to make use of it. One of the clearest pieces of evidence is the Levallois technique, the foundation of the Mousterian stone tool culture. To create a sharp stone blade, the toolmaker could not strike the stone at random, but had to visualize the final shape in advance, then remove each flake in the correct sequence. Their weapons were also far more complex than the image of a crude wooden club, and extensive archaeological evidence shows that Neanderthals attached stone points to wooden shafts using birch tar. This adhesive could only be produced by heating tree bark in a low-oxygen environment under controlled temperatures. Fire was also an essential technology. At many archaeological sites, such as Abric Romani in Spain and Paich de la Zaye in France, researchers have discovered multiple layers of hearths repeatedly used in the same areas. This shows that Neanderthals not only knew how to maintain fire, but also understood how to organize their living spaces. During long winters, a hearth provided more than warmth. It became the center of the entire community. What truly distinguished Neanderthals, however, was the way they hunted. At La Côte de Saint-Brelade on the island of Jersey, extensive evidence suggests that Neanderthals repeatedly hunted large animals at the same location over a long period of time. The Neanderthal diet was also far more varied than previously believed. Stable isotope analysis shows that they were hunters positioned near the top of the food chain. But studies of microfossils preserved in dental calculus also prove that they ate seeds, berries, mushrooms, tubers, and many other types of plants. This shows that Neanderthals did not depend on a single food source. When the environment changed, they changed with it. Each hunt not only met immediate needs, but also prepared them for the weeks ahead. But if they could plan, control fire, produce adhesives, and organize highly strategic hunts, could there also have been a far more complex inner world and capacity for thought behind those stone tools? For a long time, Neanderthals were often portrayed as strong but slow, capable of little more than instinctive reactions. Yet modern technologies such as CT scanning, microscopic wear analysis, material chemistry, and experimental archaeology are telling a completely different story. What astonishes scientists is not that Neanderthals used tools, but the way they thought in order to create them. One clear example is birch tar. To produce this adhesive, they had to heat tree bark in a low-oxygen environment at a controlled temperature for several hours. This suggests that Neanderthals did not learn only through trial and error, but were also capable of remembering and passing technical procedures on to later generations. At many sites in France, Germany, and Poland, archaeologists have discovered flint transported from sources located more than 60 miles away from the places where Neanderthals lived. This shows that they knew exactly which types of stone were suitable for making tools and planned hunting expeditions or long-distance journeys in advance. At Abric, Romani in Spain, layers of ash, hearths, tool-making areas, and places where prey was processed were arranged separately across repeated periods of occupation. This suggests that they organized their living spaces in a systematic way. At Molodova in present-day Ukraine, archaeologists also discovered a circular structure made from hundreds of mammoth bones, dating to approximately 44,000 years ago. Although its exact function remains debated, the discovery suggests that Neanderthals were capable of constructing and organizing their living environments in ways far more complex than previously believed. One of the most remarkable discoveries was announced in 2016 at Bruniquel Cave in southern France. About 1,100 feet inside the cave, where there is no natural light at all, scientists discovered nearly 400 broken pieces of stalagmites deliberately arranged into circular formations. To complete it, Neanderthals had to carry light deep into the cave, coordinate multiple individuals, and follow a shared plan. The surprises continued when Mousterian stone tools were discovered on several Mediterranean islands, including Crete and Naxos. Because these islands were never completely connected to the mainland, even when sea levels were at their lowest, some researchers suggest that Neanderthals may have used simple watercraft to cross short stretches of open sea. Even their brains reflected remarkable adaptation. With an average volume of approximately 1,450 to 1,600 cubic centimeter, larger than that of modern humans, the Neanderthal brain contained highly developed regions associated with visual processing and motor control. Neanderthals were capable of planning, selecting materials, organizing living spaces, developing technologies, and perhaps creating structures whose meaning we still do not fully understand. Perhaps the greatest mistake made by modern humans was not underestimating Neanderthal tools, but underestimating Neanderthal intelligence itself. For decades, many scientists believed that inner life was the final boundary, separating Homo sapiens from Neanderthals. One of the most moving discoveries came from Shanidar Cave in Iraq. There, archaeologists found the skeleton of Shanidar I, a Neanderthal who lived approximately 45,000 to 50,000 years ago. He had lost nearly all of his right forearm, suffered a severe injury to one leg, and had impaired vision and hearing. With injuries like these, hunting independently would have been nearly impossible, yet he survived for many more years. A similar case was discovered at La Chapelle-aux-Saints in France. The skeleton of an elderly Neanderthal showed that he had lost nearly all of his teeth many years before his death. This suggests that the community may have prepared soft food for him, or cared for him over a long period of time. Discoveries like these do not prove that Neanderthals possessed compassion in the way modern humans understand it, but they do show that their social bonds extended far beyond immediate survival needs. The next question is, how did they treat the dead? This remains a highly debated subject. However, at sites such as Shanidar, Kibara, and La Chapelle-aux-Saints, several skeletons have been found in pits that show signs of deliberate digging. Their ability to communicate is also being re-evaluated. Neanderthals carried a variant of the OXPEC2 gene, which is associated with language processing in modern humans. The hyoid bone discovered at Kibara Cave also had a structure very similar to ours, suggesting that they were capable of producing a wide range of complex sounds. The evidence for symbolic thought is even more surprising. In 2018, a study published in Nature determined that red markings in caves such as La Pasiega, Maltreviso, and Ardales in Spain were more than 64,000 years old. This means they appeared at least 20,000 years before Homo sapiens reached the region. If the dating is accurate, then the creators of those markings were almost certainly Neanderthals. The use of mineral pigments to create signs suggests that they had begun producing symbols that went beyond the needs of survival. Another example is Brunicle Cave in southern France. About 1,100 feet deep in complete darkness, Neanderthals arranged nearly 400 pieces of stalagmites into deliberate circular formations approximately 176,500 years ago. But the fact that multiple people worked together to create a structure that did not directly serve survival needs suggest that they may have possessed social or symbolic activities whose meaning we still do not fully understand. Of course, science always requires caution, and the bone once called the Divja Babe flute remains controversial because many researchers believe the holes in the bone may have been created by hyena bites. And just as we begin to realize that Neanderthals were more like us than ever before, history enters its most dramatic chapter. Another human species began moving into Western Asia and then Europe. That encounter not only changed the fate of the Neanderthals, but also changed the course of our own history. Around 60,000 to 50,000 years ago, groups of Homo sapiens left Africa, crossed the Levant, and moved into Western Asia and Europe. They did not enter an empty land. Before them lay the homeland of the Neanderthals, humans who had lived there for nearly 400,000 years. This was the first time since the two lineages split from a common ancestor, approximately 550,000 to 765,000 years earlier, that two intelligent human species existed in the same region. Constant climate shifts caused their territories to expand and contract, creating repeated periods of contact that lasted for thousands of years. Neanderthals were shorter, with sturdy bodies, broad chests, and well-developed muscles adapted to cold climates. Homo sapiens were taller and more slender, better suited to long-distance migration. But if they stood around a fire at night, the differences between them may not have been as great as we imagine. For many years, it was believed that Homo sapiens quickly replaced Neanderthals because of superior technology. Although it remains impossible to confirm that the two groups directly learned from one another, these discoveries suggest that they at least observed and were influenced by the presence of the other. Of course, this coexistence also involved competition, as both hunted reindeer, wild horses, bison, and mammoths. Both needed safe caves and access to the migration routes of animal herds. When the climate grew colder or food became scarce, conflict was difficult to avoid. But competition does not necessarily mean warfare. In a hunter-gatherer world, simply reaching a reindeer herd a few days earlier could be enough to force the other group to change its plans. The greatest turning point came in 2010, when Svante Pääbo's team at the Max Planck Institute published the first Neanderthal genome. The results surprised the entire scientific community. Most modern humans with ancestry outside Africa carry approximately 1 to 2% Neanderthal DNA. This could only have happened if the two human species had children together. The discovery overturned the belief that Neanderthals and Homo sapiens were completely separate. They did not merely meet, they became part of each other's genetic history. Later studies continued to strengthen this conclusion, as the approximately 40,000-year-old skeleton known as Prehistoric Odyssey 1 from Romania carried 6 to 9% Neanderthal DNA, indicating that this individual had a Neanderthal ancestor only about 4 to 6 generations earlier. At Denisova Cave in Siberia, scientists also discovered the girl known as Denny, whose mother was Neanderthal and whose father was Denisovan. What is especially fascinating is that segments of Neanderthal DNA continue to influence us today. Some gene variants help strengthen immune responses when the ancestors of Homo sapiens entered Eurasian environments, while others are associated with adaptation to cold climates or energy metabolism. But if the two species lived together, exchanged genes, and perhaps even shared knowledge, why did Neanderthals disappear from the fossil record only a few thousand years later? Around 40,000 years ago, the last Neanderthal fossils gradually disappeared from Europe. There are no traces of destroyed cities, no battlefields filled with human bones, and no evidence of a catastrophe like the asteroid impact that once wiped out the dinosaurs. A human species that had survived for nearly 400,000 years and endured many harsh ice age cycles quietly vanished from history. What happened? For decades, the common answer was that Homo sapiens were more intelligent and therefore replaced Neanderthals. But discoveries made over the past several decades suggest that this explanation is far too simple. As a result, most scientists today believe that no single cause led to their disappearance. The first factor was climate. From approximately 50,000 to 40,000 years ago, Europe experienced many extremely rapid changes. Data from Greenland ice cores and marine sediments show that the climate repeatedly shifted between cold and warm conditions within only a few generations. As the environment changed, herds of reindeer, wild horses, bison, and mammoths also changed their migration routes or declined in number. This meant that familiar food sources became increasingly difficult to find. However, climate cannot explain the entire story. Another hypothesis considered by scientists is disease. When the two human species came into contact and had children together, they may also have exchanged viruses and bacteria. However, the most important discovery came from genetics. When all the DNA fragments preserved in modern populations are combined, approximately 20% of the Neanderthal genome still survives scattered across modern humans. This shows that part of the Neanderthal population never truly disappeared. Over many generations of interbreeding, they gradually became integrated into Homo sapiens communities. For this reason, a growing number of researchers believe that the disappearance of Neanderthals was not an extermination, but a prolonged process. There was no single cause. Instead, multiple factors acted together over thousands of years. In 2010, a research team led by Svante Pääbo at the Max Planck Institute for Evolutionary Anthropology published the first Neanderthal genome sequence. The results completely changed the way we understand human history. Neanderthals did not disappear entirely. They still survive as a part of us. The influence of Neanderthals can also be seen in many other traits. Some gene variants associated with keratin may have influenced the structure of skin, hair, and nails, helping the body adapt more effectively to cold and dry climates. Perhaps the greatest value of these discoveries is not only that they help us understand Neanderthals, but also that they help us understand ourselves more clearly. Looking back across their entire journey, perhaps the question, have Neanderthals disappeared, is no longer as important as another question. How different are we from them, really? The story of the Neanderthals, therefore, did not end in the caves of the Ice Age, but continues quietly within the story of humanity today. The story of the Neanderthals is not one of failure, but of a resilient human species that once mastered the Earth. Archaeological and genetic evidence confirms that they possessed intelligence, sophisticated technology, and rich social lives. To understand the Neanderthals, therefore, is to better understand our own place in the ongoing story of life. Before us, another human species ruled the frozen lands of Europe. They hunted giant mammoths and survived below -20 degrees Celsius. Then they vanished, leaving only fossils and traces of DNA within us. Who were the Neanderthals? What wiped out the humans who conquered the Ice Age? To understand how Neanderthals survived for more than 300,000 years in the frozen landscapes of Europe, we must begin with one fundamental truth. They did not conquer the Ice Age. The Ice Age shaped them. For most of their existence, Neanderthals lived through relentless cycles of extreme cold. When temperatures across much of Europe were approximately 6 to 10 degrees Celsius lower than they are today. Vast grasslands repeatedly transformed into frozen steppes, winters stretched on for months, and the cold became the greatest force determining survival. Over hundreds of thousands of years of natural selection, their bodies gradually evolved to solve one overriding challenge: conserve heat and endure. The first thing that strikes anthropologists is the Neanderthal physique. A typical adult stood only about 1.64 to 1.68 meters tall, but weighed between 75 and 85 kilograms. Supported by a thick skeleton and an exceptionally powerful muscular system. This is a classic example of Bergmann's rule and Allen's rule in biology. Animals living in cold climates tend to develop larger, more compact bodies and shorter limbs to reduce the amount of surface area exposed to the environment, minimizing heat loss. The same principle can still be observed today in polar bears, musk oxen, and Arctic foxes. If the body were compared to a container of hot water on a freezing winter day, a short, rounded container would retain heat far longer than one that is tall and slender. That advantage was also evident in their noticeably shorter arms and legs, compared with Homo sapiens. The limbs lose heat faster than any other part of the body, so shortening them allowed Neanderthals to conserve significantly more energy in an icy environment. While the ancestors of Homo sapiens evolved in Africa with tall, slender bodies and long limbs adapted for releasing heat, Neanderthals developed an almost opposite body plan. Another defining feature was their large nose. Once dismissed as a coarse facial characteristic, modern research using CT reconstructions and computational fluid dynamics has revealed that the Neanderthal nasal cavity functioned like a natural climate control system. Cold, dry air was warmed and humidified before reaching the lungs, helping protect the respiratory system from the strain of taking tens of thousands of breaths every day in temperatures below freezing. Their rib cage was also broader and deeper than that of modern humans. Modern metabolic models estimate that an adult Neanderthal required roughly 4,500 to 6,000 kilocalories each day, and that demand may have exceeded 6,500 kilocalories during winter or periods of intense hunting. Even their brains reflected this remarkable adaptation. The average Neanderthal brain measured approximately 1,450 to 1,600 cubic centimeters, matching or even exceeding the average size of the modern human brain. Brain size alone, however, does not indicate greater intelligence. Part of that larger volume was associated with their larger bodies and the increased demands of processing movement, vision, and sensory information in a harsh environment. What truly mattered was that they possessed more than enough cognitive ability to coordinate complex group hunts, craft sophisticated tools, memorize vast landscapes, and adapt to one of the most unforgiving ecosystems ever inhabited by humans. Yet this is where a paradox began to emerge. The more muscle the body carried, and the better it became at conserving heat, the more energy it required simply to stay alive. They could not survive on a handful of seeds or sparse meals the way many later Homo sapiens communities eventually could. They were forced to hunt large game again and again. Their greatest battle, therefore, was never simply against the cold itself. It was against the gigantic animals of the Ice Age, fighting for every meal and every additional day of survival. Their battlefield was the Mammoth Steppe, a vast cold grassland ecosystem stretching from Western Europe to Siberia. This was not a land buried under ice and snow as many people imagine, but a dry, freezing steppe inhabited by woolly mammoths, woolly rhinoceroses, ancient bison, wild horses, and reindeer. These herds of giant animals sustained Neanderthals for hundreds of thousands of years. Their diet contained a very high amount of animal protein, placing them near the top of the food chain, alongside wolves and cave hyenas. This overturns the old idea that Neanderthals were merely scavengers feeding on animal carcasses. Among their prey, reindeer were the most stable food source. At many sites in France, Germany, and Belgium, reindeer bones make up the majority of animal remains found, showing that they did not hunt randomly but relied on experience accumulated and passed down through generations. But nature was not always generous. When reindeer herds changed their migration routes or winters lasted longer, Neanderthals had to face animals far more dangerous. An ancient bison could weigh nearly a ton. A woolly rhinoceros could weigh 2 to 3 tons, with a horn powerful enough to throw any predator into the air. And a woolly mammoth could exceed 6 tons. How could a group of people armed only with stone-tipped spears bring down such giants? Neanderthals knew how to use terrain to reduce risk. They hunted near ravines, steep riverbanks, or narrow points along migration routes, where prey had difficulty turning or escaping. In the past, many scientists believed Neanderthals drove entire herds over cliffs. However, more recent studies are more cautious and suggest that the evidence is not strong enough to confirm this scenario. Their weapons also reflected that strategy. Mousterian spears with stone tips made through the levelose technique were mainly designed for close-range thrusting, not long-distance throwing like the spears of later Homo sapiens. A large animal not only provided hundreds of kilograms of meat, but also offered the most valuable source of energy in the Ice Age. Fat. In a freezing environment, fat produces more than twice as much energy per gram as protein and was essential fuel for maintaining body heat. Neanderthals also extracted fat-rich marrow. In some places, there is even evidence that they heated bones to recover the remaining fat inside. But what is fascinating is that the value of prey did not end with food. After the meat and fat were shared, the hides, tendons, and bones became the materials that helped the entire community survive the winter. Neanderthals transformed the outcome of every hunt into clothing, tools, and other survival technologies. From this point on, the story was no longer just about hunting. It became the story of how they turned nature into an ally, allowing them to survive for more than 300,000 years in one of the harshest environments on Earth. Bringing down a mammoth or a bison was only the beginning. The real battle for Neanderthals began after the hunt. In the middle of the Ice Age, when temperatures often dropped below -20 degrees Celsius, meat could only keep them alive for a few more days. To survive through long winters, they had to preserve warmth. Animal hides, animal fat, and fire were the three foundations that shaped Neanderthal survival technology for more than 300,000 years. The first precious resource was animal hide. More than 100,000 years ago, there were no woven fabrics or clothing like we have today. If the body lost heat too quickly, hypothermia could take a life within just a few hours. That made every hide valuable. Reindeer or wild horse hides were enough for basic protection. But in the coldest regions, the thick fur of bison, cave bears, or young mammoths retained heat far better. Neanderthals did not simply drape animal skins over their bodies, but knew how to clean them, scrape away fat and tendons, and make the hides durable, flexible, and usable for longer periods. But warm clothing solved only half the problem. For the body to keep generating heat, they needed an enormous source of energy. And in a frozen environment, fat mattered even more than meat. Protein helps build muscle, but if a person eats only lean meat for a long time without enough fat, the body can still collapse. This condition was once recorded among Arctic hunting communities and is known as rabbit starvation, when the body has too much protein but not enough energy. Neanderthals seem to have understood this through direct experience. After removing the meat, they also smashed long bones open to extract fat-rich marrow. In their world, every gram of fat could decide survival. The final and most important element was fire. Today, most scientists agree that Neanderthals controlled and used fire with great skill. Fire was not only for warmth, it helped cook food, made meat and plants easier to digest, and reduced the energy the body had to spend on eating. Fire also helped dry animal hides, repair hunting spears, craft tools, and drive away predators. Many archaeological sites show that hearths were placed in very stable locations, proving that Neanderthals knew how to organize their living spaces with intention and planning. When we put all these pieces together, we realize that Neanderthals built an entire survival system. Hunting the right prey, using every hide, extracting every gram of fat, and keeping the fire alive as the heart of the community. And it is precisely when studying the tools they left behind that scientists discovered an even more surprising truth. Neanderthals did not simply use technology to survive. They continuously improved that technology. If animal hides, fat, and fire were the foundations that helped Neanderthals survive in the cold, then an even greater question remains. How did they maintain that way of life for more than 300,000 years? The answer does not lie in muscle, but in intelligence. To hunt large animals, keep fire alive through winter, and craft weapons strong enough to last, they needed more than instinct. They needed the ability to plan, experiment, and pass experience down. That is why growing archaeological evidence shows that Neanderthals were not primitive humans, but among the first engineers of the Ice Age. The clearest evidence is the Mousterian stone industry, found across Europe and Western Asia. Their tools may look simple at first glance, but the way they were made was highly sophisticated. Instead of striking stone at random, Neanderthals used the levallois technique to prepare a stone core before removing a flake whose size and shape had almost been planned from the beginning. This required the toolmaker to imagine the final product in advance, and then carry out each step in the correct sequence. Neanderthals favored flint, chert, or quartzite because they produced sharper and more durable cutting edges. At many sites in France, Germany, and Belgium, archaeologists have traced the origins of these stones to sources dozens of kilometers away from where Neanderthals lived. Stone points were attached to wooden shafts, tied with animal tendons or plant fibers, and fixed in place with adhesive. Each component had its own function, but when combined, they created a spear strong enough to face bison, rhinoceroses, or mammoths. This is one of the earliest examples of composite tools in human history. What especially impresses scientists is that Neanderthals knew how to make birch bark tar roughly 200,000 years ago. This adhesive could not appear simply by throwing bark into a fire. To create it, birch bark had to be heated in low oxygen conditions, with a temperature controlled steadily enough for the resin to separate instead of burning into ash. Another example often mentioned is the Schöningen wooden spears in Germany, dating to roughly 300,000 years ago. Although they most likely belong to Homo heidelbergensis, a very close ancestor of Neanderthals, and cannot yet be confirmed as tools made by Neanderthals themselves, they reflect the technical level of the evolutionary line that led to them. These spears, more than 2 meters long, were balanced with a center of gravity similar to modern throwing javelins, helping increase accuracy and thrusting force. This shows that weapon making was based on experience accumulated over many generations, not chance. If such complex skills were maintained for hundreds of thousands of years, there must have been a way to transmit knowledge between generations. And that is the key that opens the next part. How did Neanderthals communicate, care for one another, and build communities capable of preserving their culture across thousands of generations? Everything had to be learned from those who came before. And this is reflected in the astonishing consistency of Mousterian tools across many sites in France, Germany, Belgium, and Spain over tens of thousands of years. Such complex techniques could only have been maintained through observation, guidance, and teaching between generations. This shows that Neanderthals had more than instinct. They possessed a culture capable of preserving knowledge. Studies suggest that Neanderthals usually lived in groups of about 10 to 30 individuals. This size was small enough to move with animal herds, but large enough to hunt, share food, and protect one another. The most moving evidence comes from Shanidar Cave in Iraq. There, archaeologists discovered Shanidar I, a man who had suffered a broken arm, a leg injury, skull trauma, and possibly the loss of vision in one eye. Despite carrying many serious injuries, he lived for many more years. In a world where every meal had to be won through dangerous hunts, that would have been almost impossible without care from the community. Another case is La Chapelle aux Saints in France. This individual lived to around 40 to 50 years old, which was quite old for prehistoric times, even though he had lost almost all of his teeth. A person who could not chew tough food would have had great difficulty surviving alone. It is highly likely that members of his group prepared softer food or helped him with daily life. This shows that Neanderthal communities did not value only the strong, but also cared for the old and the weak. A society like that could not exist without communication. For many years, people believed Neanderthals only produced simple sounds. However, recent studies have changed this view. Fossils from Kibara Cave show that their hyoid bone was almost identical to that of modern humans, an important structure involved in speech. Although we still cannot confirm that Neanderthals had language as complex as Homo sapiens, most scientists today agree that they very likely possessed a communication system developed enough to plan hunts, teach skills, and organize community life. When combined with evidence of technology and mutual care, the picture of Neanderthals becomes completely different from what we once imagined. What is worth noting is that none of these actions directly made them stronger or faster. They spent time raising children, caring for the elderly, and supporting the injured. Activities that consumed resources, yet helped the entire community preserve knowledge and remain connected across generations. That is also one of the most important foundations of human society. If technology helped Neanderthals master nature, and community spirit helped them endure the Ice Age, then their most astonishing leap appeared when they began doing things that did not directly help them survive. They spent time on activities that did not bring in more food, did not protect them better from the cold, and did not make hunting easier. One of the clearest pieces of evidence comes from eagle talons discovered at sites such as Krapina in Croatia, Cova Foradada in Spain, and many other locations in France and Italy. On these talons, archaeologists found very precise cut marks made by stone tools. What is especially remarkable is that, under a microscope, many of them also show wear patterns suggesting they may once have been strung into necklaces or attached to clothing. Around 130,000 years ago, Neanderthals may have worn these talons as ornaments or as symbols of status, courage, or personal identity. In many caves across the Iberian Peninsula, Neanderthals collected red ochre, manganese, and other color-producing minerals. These were not food, and they were not suitable for making tools. A groundbreaking discovery published in 2018 changed how we see them even further. Using uranium-thorium dating, scientists determined that some paintings in the caves of La Pasiega, Maltravieso, and Ardales in Spain were more than 64,000 years old. At that time, Homo sapiens had not yet appeared in Western Europe. Perhaps the most mysterious example is Bruniquel Cave in southern France. More than 300 meters from the cave entrance, in total darkness, archaeologists discovered over 400 broken pieces of stalagmite arranged deliberately into circular structures. Burn marks show that Neanderthals brought fire into this place around 176,000 years ago. What is striking is that the area shows no signs of hunting or long-term habitation. To this day, no one knows exactly what this construction was for. It may have been a gathering place, a site for communal ritual, or something carrying a symbolic meaning that has been lost to time. Another subject that has reshaped scientific thinking is how Neanderthals treated the dead. At La Chapelle aux Saints in France, Shanidar in Iraq, and Teshik Tash in Uzbekistan, many skeletons have been found in pits that appear to have been prepared in advance. When all these pieces of evidence are brought together, from eagle talons, red pigments, and the mysterious structures inside Bruniquel Cave to the burial of the dead, the image of Neanderthals becomes completely different. The distance between Neanderthals and us, therefore, becomes smaller than ever. They were not only hunters of the Ice Age, but humans capable of reflection, creativity, and the search for meaning beyond the struggle against nature. And yet, just as they reached the height of their adaptive and cultural abilities, history suddenly changed direction. After more than 300,000 years of existence in Europe, Neanderthals began to disappear. And the true cause of that disappearance turned out to be far more complex than the familiar idea that they were simply replaced by Homo sapiens. For decades, people believed they were defeated by Homo sapiens in direct competition. But new research in archaeology, genetics, and paleoclimate shows that the story was far more complex. Neanderthals did not disappear because of a single cause, but because many factors happened at the same time, right when they had become most vulnerable. The first factor was climate. The irony is that Neanderthals were never defeated by the cold. Across more than 300,000 years of existence, they had survived many harsh glacial periods. What truly threatened them was environmental change that happened too quickly. From around 70,000 to 40,000 years ago, Europe repeatedly experienced major climate fluctuations, such as the Dansgaard-Oeschger and Heinrich events. Within only a few decades, temperatures could shift by as much as 8 to 10 degrees Celsius. Grasslands turned into forests, then back again into steppe or frozen terrain. As the environment changed, reindeer, wild horses, and bison also altered their migration routes, making hunting knowledge accumulated over many generations less effective. Another serious problem lay within their own genome. Ancient DNA shows that the final Neanderthal populations were very small and scattered across a vast region. Research on Chagirskaya Cave in Siberia suggests that some communities consisted of only a few dozen reproductive individuals. Small population size made inbreeding more frequent, reducing genetic diversity and allowing harmful genetic variants to accumulate. At the same time, small groups also had great difficulty recovering from disasters, such as harsh winters, disease, or hunting accidents. Contrary to the image of brutal wars often shown in movies, archaeology has not yet found evidence of a war of extermination between the two species. What is more likely is long-term competition for resources. Both hunted large animals across the same landscapes. When food sources had already become unstable because of climate, having to share them with another highly effective predator placed increasing pressure on Neanderthals. In addition, Homo sapiens had the advantage of broader social networks. Modern human groups often exchanged tools, materials, and connections over long distances, helping them recover more quickly from crises. Meanwhile, small and isolated Neanderthal groups became increasingly vulnerable to separation. The disappearance of Neanderthals also did not happen at the same time across Europe. As living conditions became more difficult, they gradually retreated into more favorable climatic regions, such as the Iberian Peninsula, southern France, Italy, and the Balkans. These communities were like the final embers left behind as a great fire slowly faded. They continued to exist for several thousand more years. But their numbers grew smaller, and their connections with one another gradually weakened. According to current evidence, the last Neanderthal populations disappeared around 40,000 years ago. But the story was not yet over. Neanderthals may have vanished as a separate species, but they never truly left history. When scientists began decoding ancient DNA, they discovered a startling truth. A part of Neanderthals is still alive inside the bodies of billions of people today. Around 50,000 to 45,000 years ago, the evolutionary history of humanity entered a chapter unlike anything before. For the first time, after hundreds of thousands of years of separate evolution, two intelligent human species existed on the same continent. On one side were the Neanderthals, inhabitants, who had mastered Europe for more than 300,000 years. On the other were Homo sapiens, people who had just left Africa, carrying new technologies, broader social networks, and the ability for rapid cultural innovation. Archaeological sites show that the two species lived in many regions of Europe and Western Asia at the same time for thousands of years. That almost certainly means they encountered one another many times. Perhaps they followed the same herd of reindeer, came to the same river during salmon season, or simply watched each other silently from a distance. They differed in appearance, but both knew how to use fire, make tools, and hunt the same prey. The major turning point came in 2010, when the team led by geneticist Svante Pääbo published the first Neanderthal genome. The results showed that most modern humans with ancestry outside Africa carry about 1 to 2% Neanderthal DNA. That could only have happened if Homo sapiens and Neanderthals had children together, and if those hybrid generations continued passing that DNA down through tens of thousands of years. Another discovery came in 2018, from a small bone fragment found in Denisova Cave in Siberia. Scientists identified a girl about 13 years old, whose mother was Neanderthal and whose father was Denisovan, another ancient human group in Asia. The girl, known as Deni, became the first direct evidence that ancient human groups were not completely separate. What is fascinating is that the legacy of those encounters still exists inside our bodies. Many segments of Neanderthal DNA helped Homo sapiens ancestors adapt to new environments, especially genes related to the immune system, skin, and hair. Neanderthals were not a failed species replaced by a stronger one. They were a human branch that successfully adapted to the European environment for hundreds of thousands of years. Homo sapiens, by contrast, increasingly relied on culture and the ability to innovate. When the climate changed, They improved tools, clothing, and expanded exchange networks with other communities. Both evolutionary paths were effective, but in a world that kept changing, the speed of cultural innovation provided the greater advantage. Neanderthals were not a failed branch of human evolution. They were proof of humanity's extraordinary ability to adapt to some of the harshest environments on Earth. And that reveals perhaps the most beautiful paradox of evolution. The human species, once believed to have vanished, is still present within every cell of our bodies. The legacy of the Neanderthals extends far beyond our DNA. More importantly, they forced science to rewrite the very definition of what it means to be human. Around 2.4 million years ago, human history may have begun with a single-shaped stone. Its maker was not Homo sapiens, but Homo habilis, a species whose brain was less than half the size of ours, yet left behind the first traces of human thought. Was this truly the first human, or is a crucial piece of our origin story still missing? Perhaps what made us human did not begin with a larger brain, but with the moment the mind first learned to turn nature into a tool. Between roughly 2.8 and 2 million years ago, East Africa entered a transitional period between the late Pliocene and the early Pleistocene. This was not a change that unfolded over a few years or a few generations, but across hundreds of thousands of years of geological upheaval. The East African Rift System continued to rise, reshaping the landscape, wind patterns, and rainfall across the region. At the same time, the global climate became colder and drier as ice sheets expanded across the northern hemisphere. In such a world, survival strategies that had once been effective suddenly became obsolete. Nature seemed to deliver an ultimatum to every living creature: adapt in a new way or disappear forever. Rather than favoring the strongest or the fastest individuals, it increasingly favored those who were the most behaviorally flexible. This idea lies at the heart of the variability selection hypothesis, proposed by paleoanthropologist Rick Potts of the Smithsonian Institution. According to this hypothesis, for the first time in the evolutionary history of our ancestors, the ability to adapt through behavior became just as important as the ability to adapt through physical form. What makes this story especially fascinating is that it exists not only as a hypothesis, but also within the ancient rocks of East Africa themselves. Sediment cores recovered from the Rift Valley reveal repeated cycles of lakes expanding and then shrinking over hundreds of thousands of years. At Olduvai Gorge in Tanzania, archaeologists have also uncovered numerous animal bones bearing clean-cut marks left by stone tools. The evidence suggests that Homo habilis learned to take advantage of carcasses abandoned by lions and leopards, extracting meat, marrow, and organs. Extremely valuable sources of energy for a brain that was gradually expanding. They were not the most formidable hunters on the savanna, but they were among the first creatures to transform opportunity into advantage. Earth did not give Homo habilis an easier world in which to live. On the contrary, the planet created a test so demanding that only creatures capable of learning, remembering, and innovating could pass it. On the surface, Homo habilis still resembled an ancient ape with long arms and a face that projected forward. Yet hidden behind that primitive appearance, Its brain was beginning to change in a direction that would send human history down an entirely new path. Imagine a time machine carrying us back roughly 2.2 million years ago to the grasslands near Olduvai Gorge. Among the yellowing grass, a small creature is walking silently. It stands only about 1.3 to 1.5 meters tall and weighs roughly 30 to 45 kilograms. It has a low forehead, a face that projects forward, a strong jaw, no chin, and long arms that nearly reach its knees. At first glance, most of us would not think we were standing before one of humanity's closest ancestors. We would likely assume it was simply an ape that had learned to walk on two legs. For centuries, humans imagined evolution as a climb up a staircase, every new species more complete than the one before it. But paleoanthropologists describe this phenomenon as mosaic evolution. It means that each part of the body faces different selective pressures and therefore evolves at a different pace. Homo habilis is one of the clearest living examples of that rule. Their legs had adapted better for walking upright across long distances between the increasingly sparse patches of woodland in East Africa. This helped them save more energy than moving on all fours like apes. However, the shoulders still pointed upward, the fingers remained clearly curved, and the arm bones were still unusually long. Traits almost perfectly suited for climbing. During the day, they could cross the grasslands in search of food. But when night fell, the trees remained a safe refuge from leopards, giant hyenas, or saber-toothed cats. Homo habilis seemed to live in two worlds at once. One foot had already stepped onto the ground, but part of the body was still not ready to leave the branches behind. Even the skull tells that same story of transition. The brain volume of Homo habilis ranged only from about 510 to 700 cubic centimeters, roughly half that of Homo sapiens today. Judging by the number alone, the difference may not seem significant. That helps explain why Homo habilis could survive in a world where, physically, they had almost no advantage. They could not run as fast as antelopes, were not as strong as hyenas, and had no claws or fangs to confront predators directly. Perhaps the greatest wonder of Homo habilis is that they were still not fully human. That is the beauty of evolution. It creates transitional creatures where the old and the new exist together in a single body. And from that body, which still seems so primitive, an even greater revolution was quietly unfolding. That revolution was no longer found in outward appearance, but in the way the brain began to organize thought, make plans, and turn an idea into reality. We cannot see the lost neurons, but we can see the footprints they left behind. One of the most remarkable discoveries is the change near Broca's area, the region in the left hemisphere of the modern human brain that plays an important role in controlling language and programming complex sequences of movement. This does not mean Homo habilis could speak the way we do. There is currently no scientific evidence confirming that. But many researchers believe their brains had begun to develop the neural foundation needed for forms of vocal communication, gestures, and facial expressions more sophisticated than those of other primates. More importantly, this same neural network also helped coordinate the hands in carrying out multi-step actions with increasing precision. That is the difference between picking up a stone and making a tool. A chimpanzee today can also use a stone to crack nuts or break off a branch to extract termites. What is astonishing is that experimental archaeologists today have recreated the Oldowan tool-making process and found that even untrained modern humans often fail after many attempts. So did the brain develop first in order to create tools? Or did tools themselves push the brain to evolve? Today, more and more evidence supports a balanced answer. These two processes likely formed an evolutionary feedback loop. A more flexible brain made tool making more effective. More effective tools made it possible to extract meat and especially bone marrow, an energy-rich source of fat that the brain desperately needed. A brain supplied with more energy continued to develop, allowing increasingly refined tools to emerge. This was not a sudden leap, but a chain of small improvements accumulated across hundreds of thousands of generations. For the first time in evolutionary history, a creature was not merely reacting to the world in front of it, but could imagine an object that did not yet exist, make a plan to create it, and repeat that process again and again. That was the moment thought began to rise above instinct. And when an idea could be turned into reality by the hands, the brain of Homo habilis opened the next chapter of human history. That chapter would not begin with a grand invention or a massive structure, but with a tiny object that seemed almost worthless. A stone transformed into technology by the first humans. More than 2 million years ago, the peak of human technology was only a sharp-edged stone. At first glance, the tools of the Oldowan industry may seem too simple to be called technology. To turn it into a tool, Homo habilis had to see and advance a shape that did not yet exist. They needed to choose the right kind of stone, one capable of fracturing into a sharp edge, such as basalt, quartzite, or volcanic rocks suited to each region. Then they had to identify and calculate the angle of impact, and adjust the force with enough precision to create a thin flake with a sharp cutting edge. Just one wrong angle or one strike that was too forceful, and the entire stone core could crack apart and become useless. This was a process made up of multiple consecutive steps requiring memory, prediction, and motor control. Imagine a Homo habilis individual walking past a stony streambed. There was no food in front of them yet. A few hours later, when they discovered the carcass of an antelope recently abandoned by lions, that tool finally proved its value. With a stone flake no larger than the palm of a hand, they possessed an artificial tooth, sharper than any tooth evolution had ever given them. At Olduvai Gorge in Tanzania, Kubi Fora near Kenya's Lake Turkana, and Ledi Gararu in Ethiopia, thousands of Oldowan tools have been found alongside animal bones, bearing highly distinctive cut marks. Under an electron microscope, microwear analysis on the surface of the tools also shows that they were not used only for cutting meat. Some tools were once used to scrape wood, process plants, separate tubers, or cut other soft materials. This shows that Homo habilis had learned to apply the same principle to solve many different problems. Homo habilis did not simply pick up any stone beneath their feet. They remembered the locations where good stone could be found, returned to collect it, and carried it with them as they moved. This is evidence that they had learned to invest effort in the present in exchange for benefits in the future. An extremely early expression of planning. Even more notably, recent discoveries at Lomekwi 3 in Kenya suggest that crude stone tools may have appeared around 3.3 million years ago, earlier than the emergence of the genus Homo. So what allowed the Oldowan industry to avoid disappearing along with the toolmaker who created it? At some point in evolution, Homo habilis crossed a threshold. They did not merely create tools. They began to pass down the way to create tools. And in that moment, evolution began to become a story of memory. Chimpanzees can observe and imitate one another's behavior, such as using stones to crack nuts or sticks to extract termites. Jane Goodall once recorded at Gombe in Tanzania that these behaviors exist as local traditions, but they are very easy to break. If the previous generation disappears, the skill can disappear with it. But with Homo habilis, something different began to take shape. Knowledge was not merely copied, but learned through a structured sequence. Scientists call this mechanism social learning, which includes observation, imitation, and the repetition of behavior. Beside a stream in East Africa, an adult individual is striking a piece of basalt, while several younger individuals watch nearby. They see how the stone is rotated, how the force of the blow changes when the edge is not sharp enough, and how the toolmaker stops to inspect the flake. These observations created what researchers call protoculture. Studies of modern primates help clarify this difference. Chimpanzees in different regions can develop their own tool cultures, but these cultures do not form complex cumulative chains. By contrast, in modern humans, each generation can build upon the achievements of the generation before it, creating what is known as cumulative culture. If Homo habilis had taken the first steps into structured social learning, then that meant they had begun to live in a second world. The world of knowledge slowly accumulating over time. This created an unprecedented accelerating turning point in evolutionary history. For the first time, life was no longer driven only by natural selection, but also by the flow of information between individuals. Some researchers believe that the slight development of brain regions related to sequence memory and fine motor control in Homo habilis may have supported this process of learning through observation. Although there is still no evidence of fully developed language, early forms of communication, simple sounds, hand gestures, and eye contact may have been enough to transmit basic techniques. And that invisible foundation would open the way for the next great turning point, when knowledge was no longer passed down only through observation, but began to be encoded through a tool more powerful than all others: language. Between roughly 2.4 and 1.4 million years ago, the Rift Valley region of East Africa, especially Olduvai Gorge in Tanzania and the Turkana Basin in Kenya, was not the stage of a single evolving species, but a complex branching picture. Fossil data from Smithsonian Human Origins and numerous stratigraphic studies show that at least 3 major groups appeared during the same period: Homo habilis, Homo rudolfensis, and late forms of Australopithecus, followed later by early Homo erectus. What is astonishing is that they overlapped in both time and space, sharing resources, facing the same pressures of survival, yet choosing entirely different paths. But the evolutionary shock becomes even greater when we look inside the Homo family itself. Homo habilis did not merely share the world with species from other genera. They also faced sibling branches, Homo rudolfensis, with a larger skull, and especially early Homo erectus, creatures with taller bodies, longer legs, more efficient walking, and a far greater ability to travel long distances. If Homo habilis was the first craftsman, then Homo erectus began to resemble a strategic nomad. How could several species with nearly the same ancestor coexist without eliminating one another? The answer lies in a key ecological concept: the ecological niche. Each species did not compete directly over everything, but separated itself by choosing a different survival role. Paranthropus optimized itself for eating tough plants. Homo erectus began expanding its travel range and searching for resources farther away. Homo habilis, meanwhile, shows a more dangerous but more promising path. Using Oldowan stone tools to take advantage of animal carcasses and sources of protein. Microscopic cut marks on animal bones at many archaeological sites show that they were not apex hunters, but opportunists who arrived after large predators such as lions or hyenas, yet knew how to turn what was left into a valuable source of life. Studies from the Leakey Foundation and analyses from Nature Education both emphasize that the coexistence of multiple hominin species created an unusually powerful evolutionary pressure. The more versions of humans existed at the same time, the faster survival strategies could be tested. This became an important stepping stone toward a greater change: the emergence of species capable of traveling farther and expanding their territory. From here came the appearance of Homo erectus, the first to no longer stand still inside the old world, but to begin stepping beyond it. If Homo habilis was gradually entering an intellectual race with several other human species, then a life or death question still hung in the air like a biological paradox. Where did an expanding brain get the energy to survive in this world of scarcity? For Homo habilis, whose brain capacity ranged from about 510 to 700 cubic centimeters, larger than that of Australopithecus but still on a path of growth, they faced an evolutionary problem with no easy solution. There were not enough calories from plants to fuel a brain like that. Evidence from Olduvai Gorge and Kubifora shows that Homo habilis was not a predator at the top of the food chain. They often arrived after large predators such as lions or leopards, even after hyenas and vultures. Imagine a tense scene on the East African savanna. An antelope carcass lies in the grassland, surrounded by the traces of large predators. When they leave, vultures descend from the sky, and hyenas begin gnawing away the remaining soft tissue. But when everything seems to be over, a group of Homo habilis appears. In their hands are sharp-edged Oldowan stones, simple tools, yet revolutionary ones. They did not compete through speed or strength. They competed through the ability to access what no other species could easily reach: the inside of the skeleton. Archaeological studies also reveal a distinctive trace: stone tool cut marks overlapping carnivore tooth marks, proving that Homo habilis arrived later but extracted more deeply than any other species. This led to a systematic turning point. The body began restructuring itself to prioritize the brain. But the story did not stop with nutrition. Another factor quietly appeared: food sharing within the group. In an environment where animal carcasses were an unstable resource, sharing meat or bone marrow helped the entire group maintain a steadier supply of energy. An individual who knew how to strike stone better did not merely survive longer, but could also help feed others, and through that, increase the chance of passing on their skills. And precisely as this loop began to stabilize, something unprecedented in biological history appeared. Intelligence no longer served only immediate survival, but began to redefine how survival itself worked. And from that fragile yet persistent energetic foundation, an even greater transition was waiting ahead. Around 1.4 million years ago, the traces of Homo habilis gradually faded and then disappeared from the fossil record of East Africa. But the strange thing is that, at the very moment they disappeared, another human form began to flourish. Homo erectus. Archaeological evidence from sites such as Olduvai Gorge and Kubi Fora shows that there was no absolute break between these two species. This matters because it suggests that what disappeared was not knowledge, but the carrier of an older version of that knowledge. Homo erectus appeared with a taller body, longer legs, the ability to travel farther, and most importantly, a significantly larger brain, ranging from nearly 900 to 1,000 cubic centimeters, almost twice that of Homo habilis. If Homo habilis created Oldowan tools by striking stone to obtain sharp flakes in a relatively simple way, then Homo erectus turned this technique into a more structured system, leading to Acheulean technology with symmetrical hand axes. What matters was not only the more refined shape, but the thinking behind it. They had to imagine the entire final form of the tool in their mind before beginning to shape it step by step. This was a leap in planning ability, something that had already been seeded by Homo habilis, but was now expanded to an entirely new level. Imagine a group of Homo erectus at Dmanisi in Georgia, where the earliest evidence of migration out of Africa has been found. They did not simply carry tools with them, they carried a logic of survival, choosing good stone, making tools before they were needed, moving with the seasons, and coordinating within the group. According to studies from Smithsonian Human Origins, this is one of the important signs that behavioral evolution had moved beyond purely biological limits. Behavior became heritage. Fossils from Dmanisi show that Homo erectus could live in colder conditions than East Africa, something Homo habilis could almost certainly not adapt to directly. This proves that they did not evolve only in body, but also in behavioral flexibility, the ability to change survival strategies based on accumulated knowledge, rather than relying only on fixed biological instinct. In a sense, Homo habilis did not truly leave history. They simply shifted from the role of the one who acted to the one who laid the foundation. And that foundation was strong enough for another species to step onto it. Expanded beyond Africa, move past old biological limits, and begin writing the first chapters of global history. As Homo erectus began spreading across the world, a new question appeared. Not who survived, but why did only some branches continue to evolve, while others disappeared completely? The deeper we dig into the sediments of East Africa, the image of Homo habilis is no longer a clear starting point, but more like a long stretch of fog, where many early human forms coexisted. Overlapped and continuously changed. In the 1960s, when Louis Leakey and Mary Leakey discovered fossils at Olduvai Gorge, they named Homo habilis based on a simple assumption. Any species capable of making stone tools belonged to humans. As techniques such as high-resolution CT scans and 3D skull modeling have been applied, the picture has become so complex that it has created deep debate within the anthropological community. The clearest example is two famous skulls from Kubifora in Kenya, KNMR 1813 and KNMR 1470. Both were once assigned to the Homo habilis group, yet they differ to an almost unbelievable degree. KNMR 1813 has a brain of about 510 cubic centimeters, a small face, and many ape-like traits. Meanwhile, KNMR 1813 has a brain of about 510 cubic centimeters, a small face, and many ape-like traits, with a flatter and more modern-looking facial structure. This difference has split scientists into two lines of explanation. Either this is variation within the same species, such as male-female or individual variation, or they belong to two different species. With KNMR 1870 often proposed as Homo rudolfensis. The issue becomes even more complicated when discoveries at Lomekwi in Kenya indicate that stone tools may have appeared as early as 3.3 million years ago, nearly a million years before the appearance of Homo habilis. Even anatomically, Homo habilis was not entirely human in the modern sense. Many traits, such as long limb proportions, shoulder structure, and climbing ability, still carried the clear imprint of Australopithecus. This has led to a controversial proposal. Should they be called Australopithecus habilis instead of Homo habilis? Modern morphological analyses, or geometric morphometrics, from Smithsonian Human Origins and many studies published by Nature show that variation within the genus Homo during this period did not follow a straight line, but took the form of an evolutionary bush. Many parallel branches competing with and replacing one another over time. This combination created a new form of existence, a creature that no longer lived only by instinct, but began to live by accumulated knowledge. It continued even farther, beyond the first biological borders, leading to an even greater question waiting ahead. When knowledge becomes complex enough to describe itself, what will happen next to humanity? Homo habilis may not yet have been human by the modern definition, but they achieved something no creature had ever done on that scale before. From an Oldowan stone flake to the wheel, metallurgy, the steam engine, computers, spacecraft, and artificial intelligence, there is a chain of innovation stretching across more than 2 million years. Perhaps that was the true moment when human history began. The strangest thing in Earth's history is not the rise of humans, but that only one human species survived. Homo sapiens were never the strongest, fastest, or most numerous. So why did every other human lineage disappear, while we became the dominant species on Earth? Around 7 million years ago, the last common ancestor of humans and chimpanzees split into two different evolutionary branches. From that moment on, the history of the human family was nothing like a ladder with step after step rising upward, as many old textbooks once described. Some species appeared and then disappeared. Some species coexisted for hundreds of thousands of years. Homo sapiens was only one of many branches that once grew from that bush. What created that complex evolutionary network? Over the last 3 million years, the climate of this continent repeatedly shifted between wet and dry periods, driven by changes in Earth's orbit combined with global climate transformations. Dense forests shrank and expanded many times. Savanna grasslands spread far and then gave way to trees again. Lakes formed and then vanished. Imagine a community living around a large lake in East Africa. When a long drought arrived, the lake slowly dried out. One group had to move north, another moved south, while others crossed toward the west. Tens of thousands of years spent living in different environments caused them to accumulate their own genetic traits. That is why more and more paleoanthropologists support the Pan-African origin model. According to this model, Homo sapiens was not born in a single cradle in East Africa, as the traditional view suggests, but formed from a network of ancient human populations spread across Africa, constantly connecting and exchanging genes with one another. Archaeological discoveries over the past 2 decades have strongly reinforced that picture. In 2017, scientists announced fossils from Jebel Irhoud, Morocco, dated to around 315,000 years ago, now considered among the oldest known Homo sapiens fossils. What is astonishing is that this site lies more than 3,100 miles, or about 5,000 kilometers, away from the regions of East Africa. Meanwhile, the Homo I fossil in Ethiopia has been dated to about 233,000 years old, while Herto is about 160,000 years old. Genome analyses of thousands of modern people show that Africa today still has the highest level of genetic diversity in the world, reflecting a long evolutionary history in which many populations once lived apart and then repeatedly blended together. And yet, if we could meet the first Homo sapiens, we might be surprised by how familiar they looked. They already had relatively flat faces, skulls that were rounder than those of earlier Homo species, bodies adapted for long-distance walking, and hands skilled enough to make refined stone tools. They knew how to hunt, gather, exploit many food sources, and survive in very different environments. However, for tens of thousands of early years, they were still only one human species among many others. If modern appearance, skillful hands, and the ability to make tools were still not enough to help Homo sapiens dominate the planet, then what created the turning point? For decades, scientists once believed that the larger the brain, the higher the intelligence. But fossils have told a completely different story. The brain of Homo sapiens today has an average volume of about 82 cubic inches, or around 1,350 cubic centimeter, while many Neanderthal individuals reached between 88 and 98 cubic inches, or about 1,450 to 1,600 cubic centimeter. And yet, around 40,000 years ago, they disappeared, while Homo sapiens spread across almost every continent. That shows The decisive factor was never simply a larger brain. The skull of Homo sapiens tends to be rounder, reflecting a restructuring of the brain during development, especially in the parietal region and the cerebellum, areas linked to information integration, planning, memory, and the coordination of complex cognitive activities. However, Homo sapiens seems to have possessed a special advantage: the ability to connect many separate ideas and create entirely new concepts. Homo sapiens could sit around a fire, imagine a hunt that would take place many days later, predict that a herd of antelope would move with the seasons, calculate how much water to carry, and divide tasks among each member before the hunt began. Imagine a group of hunters around 70,000 years ago. They did not chase after prey the moment they saw it. They observed footprints still pressed into the ground from the day before, read the direction of the wind, chose an ambush point many miles away, and then waited patiently. But the greatest wonder lay in another ability: symbolic thinking. Homo sapiens began to see more than what their eyes could observe. Archaeological evidence at Blombos Cave in South Africa shows that from around 75,000 to 100,000 years ago, Homo sapiens had carved geometric patterns onto ochre and made shell beads to wear on their bodies. These objects did not make hunting more efficient, nor did they create more food. Their value lay entirely in symbolic meaning. It was a sign that humans had begun to think beyond the physical world in front of them. From that moment on, the human brain did not only remember facts, but also created invisible realities. Rules, honor, belief, gods, and later money, nations, and science could not be held, weighed, or measured. This was one of the most important turning points in evolutionary history. Homo sapiens could connect much larger communities through shared symbols and shared beliefs. That variability opened the way for division of labor, trade, religion, states, and eventually the entire civilization of humanity. However, for the cognitive revolution to truly change history, those thoughts had to be transmitted with increasing accuracy from one brain to another, from one generation to the next. And that was when Homo sapiens possessed the most powerful technology ever to appear on Earth: language. This was not merely a tool for communication. It was the first technology that allowed knowledge to be stored, copied, and improved without waiting for genetic mutations to accumulate over thousands of generations. Humpback whales sing songs that can last for tens of minutes and travel for dozens of miles through the ocean. Honeybees perform the famous waggle dance, to indicate the direction and distance of flowering plants. Vervet monkeys produce different alarm calls when they spot eagles, leopards, or snakes, and each sound triggers a distinct response from the entire group. These systems are remarkably sophisticated, yet they all share the same limitation. They primarily communicate what exists here and now. Humans can recount a hunt that took place years earlier, describe a valley hundreds of miles away, warn of a danger that has not yet appeared, or discuss an idea that has never existed in the physical world. This trait is nearly unique within human communication systems and forms the foundation of all long-term planning. A few spoken sentences could transfer experiences accumulated over many days to listeners who had never lived through them themselves. For the first time, knowledge became separated from personal experience. A stoneworker who discovered how to strike two different types of rock to create a sharper blade no longer had to carry that secret to the grave. He could teach it to his descendants, pass it on to others in the tribe, and generations later it could be refined into spears, javelins, or arrows. In evolutionary biology, this phenomenon is known as cumulative culture. But the greatest power of language was something even more extraordinary. It allowed humans to tell stories. What bound people together was no longer blood alone, but shared narratives. Who their ancestors were, who owned the land, which rules must be followed, and why people were obligated to protect one another. More importantly, everyone believed in those stories. That became the foundation of every human society that followed. The archaeological record reflects this transformation with remarkable clarity. From roughly 100,000 to 40,000 years ago, archaeologists observed a dramatic increase in jewelry, pigments, beads, cave art, figurines, and burial rituals across many regions of Africa, Western Asia, and later Europe. Even more remarkable is the fact that the brains of modern Homo sapiens are almost indistinguishable from those of their ancestors who lived approximately 40,000 years ago. Yet for the first time in Earth's history, knowledge became a form of inheritance more powerful than DNA itself. And once knowledge could be accumulated, corrected, and passed forward, rather than endlessly restarted from the beginning, a new force emerged. Faster, more flexible, and powerful enough to shape an entire planet. Cultural evolution. It was this force that would carry Homo sapiens out of Africa and begin the conquest of nearly the entire world. For nearly 4 billion years in the history of life on Earth, every species had to adapt by the same rule. Wait for random genetic mutations to appear, then let natural selection decide which mutations would be preserved. But with Homo sapiens, another path appeared for the first time. Instead of only changing the body, humans began changing knowledge. And what is astonishing is that knowledge can evolve far faster than DNA. Anthropologists call this phenomenon cumulative culture. The archaeological record shows that from roughly 100,000 to 50,000 years ago, the pace of technological innovation among Homo sapiens began to increase noticeably. Stone toolkits no longer remained unchanged for tens of thousands of years as before, but became increasingly diverse and specialized. Long blades appeared, along with smaller but sharper spear points, tools for processing animal hides, woodworking tools, and many sophisticated stone knapping techniques. Around 45,000 years ago, in Siberia and many sites across northern Asia, archaeologists discovered bone needles with eyes for threading. Only about 2 to 3 inches long, this tiny artifact marked an enormous revolution. Instead of merely wrapping animal hides around the body, Homo sapiens could cut, sew, and create clothing that fit closely to the body, trapping a warm layer of air inside. Thanks to this, they could survive in regions where winter temperatures could fall below -22 degrees Fahrenheit. But culture did not only create tools, it also created identity. Around 51,000 years ago, Homo sapiens reached Australia. Even though this continent was never fully connected to Asia, not even when sea levels were at their lowest during the Ice Age. That means they had to cross straits dozens of miles wide using floating vessels they had built themselves. This was not simply a technical achievement. It was the result of knowledge accumulated across countless generations. Alongside technological development came an explosion of spiritual life. The paintings in Chauvet Cave in France, dated to around 36,000 years ago, or the artworks on Sulawesi Island in Indonesia, at least 51,200 years old, show that humans were no longer concerned only with food and shelter. They began telling stories through images, preserving memory, passing down experience, and building communal identity. The remarkable thing is that over the past roughly 40,000 years, the genome of Homo sapiens has changed relatively little, while technology and culture have developed at an unprecedented speed. For the first time in the history of life, a species could adapt to its environment much faster by changing behavior rather than changing the body. This was the greatest advantage Homo sapiens had over every other human species. And precisely when culture began to evolve faster than genes, Homo sapiens possessed the final condition needed to carry out the boldest adventure in human history, leaving Africa and turning nearly the entire planet into their home. Around 70,000 to 60,000 years ago, a relatively small group of Homo sapiens began leaving Africa, possibly through the Sinai Peninsula or the Bab el-Mandeb Strait region of the Red Sea. Earlier waves of Homo sapiens had already left Africa before this, such as the fossils at Mislia and Skul Kavze in Israel, which show that humans were present outside Africa from roughly 180,000 to 120,000 years ago. Genetic models estimate that the founding population may have included only around 1,000 to 10,000 breeding individuals, and the number of people directly involved in each stage of migration may have been much smaller. Those footsteps quickly spread with astonishing speed. Around 65,000 years ago, Homo sapiens were already present in northern Australia. This is especially important because Australia was never connected to the Asian mainland, even when sea levels were at their lowest. That means humans had to cross straits at least about 45 to 60 miles wide, using deliberately prepared floating vessels. Around 45,000 years ago, Homo sapiens entered Europe, where they faced freezing winters and inhabitants who had lived there for hundreds of thousands of years. The Neanderthals. Farther east, human groups continued into Siberia, where winter temperatures could drop below -58 degrees Fahrenheit. They wore multiple layers of animal hides sewn tightly with bone needles, built shelters, stored fuel, and coordinated hunts of mammoths and reindeer. The peak of this expansion took place near the end of the Ice Age, when enormous amounts of water were locked inside ice caps, and global sea levels were about 390 feet lower than today, exposing a vast landmass called Beringia, which connected Siberia to Alaska. Around 20,000 to 15,000 years ago, groups of Homo sapiens crossed this land bridge or moved along the Pacific coast to enter the Americas. What is most astonishing is the number of environments they conquered. From tropical rainforests, African savannas, Arabian deserts, and the Tibetan Plateau to the subarctic, Homo sapiens found ways to survive through knowledge instead of waiting for their bodies to change. At this point, it seemed as if Homo sapiens had become the human species that dominated Earth. But when they set foot in new lands, they quickly discovered a surprising truth. This planet did not belong to them alone. In Europe, there were Neanderthals. Across many regions of Asia, there were Denisovans. And on isolated islands, other human species still existed, each with its own evolutionary history. After a migration that lasted tens of thousands of years, Homo sapiens finally reached nearly every habitable region on Earth. The strange thing is that only about 40,000 years later, all of those branches disappeared from the fossil record, leaving behind only one name: Homo sapiens. The most famous were the Neanderthals, who appeared around 400,000 years ago and dominated Europe and Western Asia through many Ice Age cycles. They were short but extremely powerful, with broad chests, thick bones, and short limbs that helped them retain heat efficiently in cold climates. They knew how to make fire, crafted tools using the highly sophisticated Lavallois technique, hunted bison, wild horses, and mammoths in groups, cared for injured individuals for years, and left evidence of burial rituals. Meanwhile, in Siberia, science uncovered an even stranger story. In 2008, at Denisova Cave, archaeologists found only a fragment of a finger bone and a few teeth. To the naked eye, it was almost impossible to know who they belonged to. But DNA sequencing technology created a turning point. Results published in 2010 showed that this was an entirely different human branch, now known as the Denisovans. Evolution on islands created other surprises as well. On the Indonesian island of Flores, scientists discovered Homo floresiensis, only about 3 feet 6 inches, 1.06 meter, tall, yet still capable of making stone tools and hunting animals. On the Philippine island of Luzon, fossils of Homo luzonensis further proved that only about 50,000 years ago, Earth was not the planet of a single human species, but a place where many human branches coexisted, each representing a different evolutionary path. Denisovans also left a similar genetic mark in many Asian and Oceanian populations. They did not completely disappear. Part of them is still living inside the genomes of billions of people. However, interbreeding is not enough to explain the whole story. DNA studies also show that they experienced long periods of low genetic diversity, which made their ability to recover from natural disasters, disease, or declining prey more limited. By around 40,000 years ago, Neanderthals disappeared from the fossil record. Denisovans, Homo floresiensis, Homo luzonensis, and other human branches also gradually left the stage of evolution. After nearly 7 million years since the human lineage split from its common ancestor with chimpanzees, the evolutionary bush that once had so many branches now had only one surviving branch left. From that moment on, Homo sapiens no longer had to compete with any other human species. And from here, instead of merely learning how to adapt to the world, humans would begin moving into a far bolder stage, changing the world itself to serve them. Around 11,700 years ago, when the last ice age ended and the Holocene began, Earth entered a rare period of climate stability. Giant glaciers melted. Sea levels rose about 394 feet compared with the glacial maximum. And forests and grasslands expanded across many continents. For the first time, environmental conditions were stable enough for a bold idea to emerge. Instead of continuing to chase food, why not make food stay with humans? Around 12,000 to 10,000 years ago, in the Fertile Crescent of Western Asia, humans began selecting wild wheat and barley plants with favorable traits for cultivation. What is interesting is that agriculture did not appear in only one place. Around the same time, other communities in the Yangtze and Yellow River basins developed rice and millet farming. In New Guinea, taro and bananas. In Mesoamerica, corn, beans, and squash. And in many parts of Africa, sorghum and millet. Humans also began changing the animals around them. Creatures that had once appeared only as prey now became stable sources of food, milk, hides, wool, and pulling power. This was the first time in the history of life that one species did not merely adapt to an ecosystem, but redesigned the ecosystem according to its own needs. Forests were cut down to open fields. Wetlands were redirected into irrigation systems. Plants and animals were selected over many generations, gradually becoming very different from their wild ancestors. As food became more stable, human groups no longer had to keep moving. The first villages appeared, then gradually grew into towns and cities. At first glance, this seemed like the perfect victory of Homo sapiens. But archaeology tells a more complicated story. Analyses of thousands of skeletons from the early farming period show that the average height of many communities declined compared with their hunter-gatherer ancestors. Diets dependent on only a few crops made nutrition less diverse. Another paradox also quietly appeared. When land could be owned, wealth could be accumulated, and food could be stored, society began to divide. Humans traded the freedom of the hunter-gatherer life for the stability of agriculture, traded relative equality for productivity, surplus, and the complexity of civilization. Yet, on the scale of the entire planet, this revolution changed Earth in an unprecedented way. The human population rose from a few million to tens of millions, and then to hundreds of millions. Forests became fields, Rivers were diverted, wetlands were reclaimed, and trade networks connected lands thousands of miles apart. And it was the distance between a Stone Age brain and an increasingly complex civilization that would lead Homo sapiens to a moment when human power was no longer limited to changing the environment, but began expanding toward changing the very future of its own evolution. But the farther we move forward, the more we discover a strange paradox. The world has changed at breathtaking speed, while the brain that created all of it has remained almost the same. If we look at the skull of a Homo sapiens who lived around 40,000 years ago, it is very difficult to distinguish it from the skull of a human today. That does not mean the brain has not changed at all. But the biological changes are very small compared with the speed of civilization's development. Since the agricultural revolution began around 12,000 years ago, humanity has passed through only approximately 400 generations. A span of time far too short for natural selection to significantly restructure the most complex organ in the body. On the African savanna, a strange sound in the bushes or the footprint of a predator could determine survival. So the brain evolved to pay special attention to things that were new, unexpected, and especially dangerous. In the 21st century, that same mechanism makes it difficult for us to take our eyes off our phones. This does not happen because humans lack willpower, but because digital platforms are exploiting neural mechanisms that were formed hundreds of thousands of years ago. In ancient environments, missing a predator could mean death, while missing a beautiful scene had almost no consequence. So the brain prioritized detecting danger above everything else. Today, when news from around the world appears continuously on screens, the brain still reacts in the old way. A single headline about war, natural disaster, or crisis can attract attention more powerfully than dozens of positive stories. Another mechanism that once helped our ancestors survive is the tendency to prioritize people who belong to our group. But in a society connected by more than 8 billion people, that mechanism sometimes contributes to polarization, prejudice, and the spread of misinformation. The brain did not evolve to process thousands of opinions every day from people it has never met. And it was certainly not designed to face social pressure from millions of people on the internet. The brain shaped in the Stone Age did not only help humans survive, it also built telescopes to explore the universe, decoded the human genome, created quantum computers, and developed artificial intelligence. And now, for the first time in nearly 300,000 years of human history, technology is no longer only changing our living environment. It is beginning to turn toward our own bodies and brains. Are we preparing to create an entirely new kind of human? From a small group of hunter-gatherers in Africa to a global civilization, Homo sapiens was not the strongest, the fastest, or the smartest species in any single sense. Every turning point in the history of Homo sapiens opened new opportunities, but also created challenges never seen before. Today, facing climate change, artificial intelligence, synthetic biology, and the journey into space exploration, we once again stand at another crossroads of evolution. For roughly 300,000 years, Homo sapiens did not win because we were the most perfect species. We won because we are the species that never stops learning, cooperating, and changing. Perhaps the greatest wonder is not how Homo sapiens rose, but that this story is still being written by us. Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.